In this video, we'll generate the dataset of exponential function and exponential decay function and the Taylor-Maclaurin series expansion for both. And we also generate the regression in LOGEST form. We begin with the exponential function, which is array formula, exponent of x from 0 to 0.8. And here you have the exponential function from 0 to 0.8. And we have b1, a b0, and b1. So to get the, if you regress that, so we use logest data y and data x. And to get the value of b1, because this is exponent b1, to get the value of b1, this is logarithm of exponent b1. So the value is 1. So here you have 1, that this is our b0, and b1 is equals 1. Next, we generate the decay function. So it is equal to array formula, exponent of the x values, enter, and we factor in the negative sign. So here's the trend line. So we have b0 equals 1, and b1 is negative 1. So this is equal to logest of data y. We'll use this one. This is logest of data y and data x. That's the negative. So here we have the value b1. To get b1, we have ln of this value. So we have this. So negative 1. So b1 is negative 1, while b0 is positive 1. Next, we generate the Taylor-Maclaurin series sum for both, where we have a times x to the power n, where n is from 0 to infinity. So in this case, we'll try to get to infinity. We'll try to get to 10, I think. 10 is good enough. And we generate the series sum. So it's the summation of a times x to the power n. So array formula, series sum of x raised to the power, starting from 0, incremented by 1. And the coefficient will be this range. Now the coefficient. It is k to the power n, where the value of k is negative 1 and 1. So data validation, list of items, negative 1 and 1. Negative 1 if it is decaying, and positive 1 if it is exponential. So we start with decaying. So this is equal to array formula, starting with the numerator. So k raised to the power n all over factorial of n. So if it is decaying, the red line is on the green data set, which is the negative exponent or the decay. If it is positive 1, the red line is on the blue, which is the exponential. Next, we regress it using logest. So logest data y, this would be our data y, and data x. And we calculate, because this is our b1, exponent b1, so our value for b1 will be equal to ln of this value. So 0.999, it's already equal to 1. So if k equals 1, these two data sets are the same, meaning the red line is on the blue data set or the blue line. So their values, their coefficients are the same. If we change k to negative 1, the red line now will be the same. The data set of the red line is on the green line. So the red and green data sets are the same. And the regression coefficients are also the same. So this completes the use of exponential function, LOGEST, and array formula to generate the exponential and exponential decay function.